Homework M1, question 7. We've been given a curve C with the following equation, and we've been asked to find dx dy in terms of x and y. Now my curve C is written in terms of x and y, so we're going to need to use some implicit differentiation here. I'm going to go across from left to right. If a term is purely in terms of x, we can differentiate it normally. If it's in terms of y, we differentiate it normally with respect to y and then multiply by dy dx. So x cubed is just going to differentiate to 3x squared. Please note I'm not starting dy dx equals because my equation isn't starting y equals. Now when it comes to differentiating 2xy, this is a product. So without showing the full working explicitly on the paper, my first term is going to be 2x, my second term is going to be y. So if I differentiate the first term, I get 2, and that allows me to keep the second term the same, y. And then I can differentiate the first term, keep the first term the same to get 2x, and differentiate the second term, and y differentiates to 1 times dy dx. Carrying across, if I differentiate minus x, that's just going to get me minus 1. If I differentiate minus y cubed, that's going to get me minus 3y squared, differentiating with respect to y, times by dy dx. Minus 20 differentiates to 0. And I do need to also differentiate the right hand side here of 0, which is 0. Now I've been asked to find dy dx, so I want to gather up all my terms. If I start by gathering up the dy dx terms on the left hand side, and I'll put them into a common bracket, then I have 2x minus 3y squared. And then if I move all my other terms across to the right hand side, that is going to give me 1 minus 3x squared minus 2y. Final thing I need to do is divide by that bracket. Dy dx is equal to 1 minus 3x squared minus 2y all over 2x minus 3y squared. And that's my final answer for part A. In part B, I'm asked to find an equation of the tangent at the point 3 minus 2, and I've been asked to give my answer in the form ax plus by plus c equals 0, where a, b and c are integers. So I need to plug in the values 3 minus 2 into my differential. So dy dx is equal to 1 minus 3 times 3 squared, so minus 27, minus 2 times minus 2, which is plus 4, all over 2 times 3 is 6, minus 3 times minus 2 squared, so it's minus 3 times 4, minus 12. If I simplify this, this is giving me minus 22 over minus 6, which simplifies to 11 over 3. Now I know my coordinate, I know my gradient, so using my formula, y minus y1 is equal to mx minus x1. I was asked to give it in a particular format, so I can't just simplify and leave it. If I multiply everything up by 3 to eliminate my fraction, that gives me 3y plus 6 is equal to 11x minus 33. And finally, if I just rearrange this to 11x minus 3y minus 39 equals 0, that is my final answer.